Algebras, and welcome to Chapter 4, Lesson 1, Day 2. So now we're going to talk about a little review of slope, a little review of the slope formula itself, and then kind of get into really how is this applied through questions like this, representing a linear relationship, looking at slope, changing into slope-intercept form, and kind of looking at, what is it comparing in different types of linear equations. So different ways that we're applying the pieces we know about slope. And let's start by reminding ourselves that there are four different types of slope. Okay? Positive, negative, zero slope, and undefined slope. And all of them have to do with the calculation of the slope of a line based on the difference in the y values divided by the difference in the x values. Okay? So that's how we calculate our particular slopes as we go. So what we're going to do first is we're going to look at our pictures, determine the type, then we're going to actually count and calculate the value of our slopes, okay? So if I can look at the picture here, I know that the type of slope, this is positive. And when I go to calculate the value of this slope, I'm going to know that the answer to this will be positive, okay? The value of this number is going to be a positive number. Let's count. So I'm looking for a point left to right, and here's one right here. Now, from here, I know that I will count up 1 and then right 2 to get to the next point. Up 1, right 2. So positive 1 up, positive 2 right. That would be a slope of 1/2. Rise over run. How much did I go up or down? How much did I go left or right? Okay, up or down, left or right. Type. This is an undefined. Undefined. And when it comes to the value of an undefined slope, what you really need to know is the top number of this fraction can be anything, but the bottom number is going to end up being a 0. And that's because your x value, your left and right, is not changing. So let's say I went from this point, count from this point to this point. Let me count. I'm only going to count down 1, 2, 3, 4. That's my top number, but it doesn't matter because there is no left or right that I can count, meaning the change in x is 0. And if the change in x is 0, this is a vertical line straight up and down, and the slope is undefined. This, as we know, is not allowed to happen. We are not allowed to divide by 0. Okay? This type, just looking at it, is negative. Sorry, I left the website up and didn't pull up my graphing calculator. There it is. This is a negative slope. The first point I see left to right is right here, the y-intercept. And now I'm going to count down until I see the next coordinate plane point. So down 1, 2, 3, 4, 5, right 1. So I went down 5, which is a negative 5 move. Then I went right 1, which is a positive 1 move. When I figure out the value of my slope, that is negative 5 over positive 1. Or you can just write a slope of negative 5. When your bottom number in your fraction is 1, you can just write your whole number as your answer for your slope. Slope can always be represented as a fraction. Sometimes it's also represented as a whole number. So it does depend. Last but certainly not least, I can really pick any point along this horizontal line, any 2 points. And notice that there is not any up or down movement. This is a 0 slope because since there is not any up or down change, there's no change in your y values, that means your top number of your fraction is 0. Doesn't matter the bottom number. 1, 2, 3, 4. Okay, it's a positive 4 on the bottom. It doesn't matter. Your entire slope is 0 because there was no change in the top number. Now notice this is different. Function only depends on the x value not being repeated. Y values can be repeated on a function. So this this, and this are all linear functions. This is just a line, and this is a vertical line. It is not a function because it has a repeated x value. Okay, that's all review stuff, but again, just wanted to make sure you know. All right, what do you look for specifically for a slope? You look for a constant rate of change. I can tell by looking at this question because of the font of it, this is a former Regents exam question. So how does the Regents ask about slopes? Well, sometimes they want you to analyze tables looking for a comparison between the change in y and the change in x. And so how we do that is look at your x's and count how are we getting from one x to the next. So from here to here, we're adding 1. 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 So the x side is a constant rate of change. For this to be a linear relationship, the y side, or in our case, the f of x side, also has to be a constant rate of change. So that's what you look for. And here you are adding 1, but here you're not. From -2 to +1, think about it. You go to -1, 0, and then 1. That's a +3 change. And then from here to here, now you've got a +5 change. And from here to here, now you've got a +7 change. This is not a linear relationship because that is not a constant rate of change. I do want you to note that all of the x values in here all have a constant rate of change of adding 1. So really, let's look at our y values and see how we're doing. So let's go to choice 2. Here we add 1/2. And here we add 1. And here we add 2. And here we add 4. Is that a constant rate of change? Was my number the same throughout all the y changes? No. This is not a linear function either. Constant rate of change is what I'm looking for. So here I'm adding 2. Here I'm adding 2. Oh, this is looking positive so far. Positive 2. This is looking good, and there we are. So this is likely my linear function, but let's just make sure that down here we don't have a linear function, and look, we don't. Okay, we add 1, we add 1, but now we add 7, and now we add 19. So definitely not a constant rate of change for choice 4. So the correct choice here being 3, that's the one that has a linear function because there's a constant rate of change on both sides. Okay, both sides need a constant rate of change. Both your change in x and your change in y need to be constant. All right, what else are we looking for? Well, you have learned before now that the slope-intercept form of a line is y equals mx plus b. And prior to now, you have learned that you need to have slope-intercept form to graph lines, y equals mx plus b form. That's fine. But now we need to manipulate our equations into y equals mx plus b form so that we can graph these lines. So the whole point is get the y all by itself, okay? Let's start by reminding ourselves here that we need to move this -3x to the other side of the equal sign so that the 4y can be alone. So we add that 3x by moving it opposite operation-wise. Bring down your 4y, bring down your equal sign, and because I'm specifically looking for mx plus b, I am going to, hey, I'll see you in a sec. I am going to put my +3 first, my +3x first with its sign, and then put my +12 next. Okay, next to it because I want the mx plus b. Okay? Now, to get the y completely alone, divide both sides by 4. So you bring down your y, bring down, oh, is slope allowed to be a fraction? The number in front of the x is your slope. The m, is that allowed to be a fraction? Yes. So 3/4 x comes down. Now, typically your y-intercept is going to be an integer. Not always, but in this case it is. Okay, so 12 divided by 4 gives me a +3 here. So now we want to state the slope and the y-intercept. Well, the slope is always the number in front of the x, and that's a +3/4. The b is always the number by itself at the end. That's the +3. Okay, let's do that again. You know, sometimes the slope in front of the x is going to be a whole number, and other times it's going to be a fraction. And more likely than not, it's going to be a fraction. So like here with b, I've got this positive x all by itself, subtract it over to b to the other side of the equal sign, bring down your negative 4y, bring down your equal sign, bring down your negative x and put that first, then bring down your positive 8 and put that second. Again, that's because I like the mx first, then the plus b second. Now, to get y completely alone, you divide everything by negative 4. So I'm dividing everything by negative 4. I get y equals, okay, in front of the x here, there's really a negative 1 that I just haven't written in front of that x, and it's being divided by negative 4. Well, negative 1 and negative 4, they don't have a common factor, so I can't reduce them, but I also can't leave a negative over a negative. So what I'll do is negative over negative I know is positive. I bring down the 1 in front of the x, and then the 4 is my numerator, or excuse me, as my denominator, and I get 1/4 x. Now at the end, 8 divided by negative 4 is negative 2. My slope is the number in front of the x, positive 1/4. My y-intercept is the number by itself at the end, that's the negative 2. On C, is there an x value? Nope. So really, all you need to do is get that y alone by dividing both sides by 2. And I end up with y equals negative 5. Now, is this still y equals mx plus b form? Yes. Is this still a line? Or excuse me, is this still a linear function? Yes. If you have a y involved, this is still a linear function. If it were just x equals negative 5, that's when it would be an undefined slope and not a linear function anymore, not a function. Okay, so this is the y equals mx plus b form of my line. It's just the number in front of the x is a 0. So my slope is a 0. That's a horizontal line. And my y-intercept is negative 5. That's a horizontal line where the y-intercept is the y value of the entire line. That's why it's y equals that number, and that's the y value to infinity in both directions. Last but certainly not least, and then these are the types of questions on your homework for this. So these are the practice. And then this is actually a former Regents exam question that I just retyped. So I do happen to know that it's already a Regents question, okay? A gardener is planting 2 types of trees in 1 yard. Tree type A, is 3 feet tall and grows at a rate of 15 inches per year. Sounds like since it's per year, that's a constant rate of change. Tree type B is 4 feet tall and grows at a constant rate, grows at a rate, I added constant because I can see it coming, of 10 inches per year. Represent each type of tree as a linear function where the slope is the rate of growth per year and the y-intercept is the starting tree height. So tree type A, 3 feet tall, grows at a rate of 15 inches per year. So that would be, let's do A of x to name our function A equals 15x plus, where did we start? 3 feet? 3. Tree type B. Let's call it B of x to name the function so that I know which one I'm talking about. Tree type B is B of x. It was starting at 4 feet tall and grows at a rate of 10 inches per year. So 10x plus 4. Now, what we're going to do is we're going to create tables where we're going to use this formula to plug in different x values, that'll be the years, and get out the heights of the tree over those years of time. Okay, so let me just kind of take a peek over here at my graphing calculator. Because I've created this function, if I press y equals, I can plug that function in right here and take a look at its table on my graphing calculator. So I don't have to do this in my head. Okay, even though I could, I don't have to. So I head over here, y equals, let's plug in 15x plus 3. And then let's press second and graph to see that function. And because we're talking about time, we're not going to be looking at negative x values. Okay, so these negative x values up here, I'm not going to look at those. I'm going to arrow down until I don't see those anymore, and I'm going to start with 0. So at the time of the planting of this tree, it's 3 inches tall. And now from now on, each year, it's growing at a rate of 15 inches per year. So you can see how we've already got these first two. Now we're going to keep going. So 2, 3, 4, 5, and up to year 6, up to and including year 6. And let's look at the matching y values. So then we've got 33 after 2 years, 48 inches after 3 years, 63 inches after 4 years. After 5 years, we're at 78. And after 6 years, we're at 93. Okay, that's how tall the tree is at each of those year markers. Now, I'm not going to delete this one. I'm not really done with it in my mind. So I'm just going to press y equals, and instead of deleting this, I'm going to arrow down so that I can enter my next type of function down here. Now, I don't want to see both, so let me arrow right and up and see how I'm highlighted on this equals. If I press enter, that's no longer highlighted. So now that line isn't going to graph until I re-highlight that equal sign. If you arrow down to y2 and come right in here and start entering your function 10x plus 4, it's automatically highlighted. Now press second and graph to see your table of points. And notice this time, because we started at 0 last time, we start at 0 automatically. And now I'm going to enter all these values. Look at this. So, okay, start with 0, 4, 114, 2, 24, 3, 34. Oh, these will be pretty easy to figure out, right? Where am I? 5, 54. And 6, 64. Okay. So if I'm just kind of looking at this, okay, I can see that one of them is starting to kind of, let's look at them both at the same time. Y equals, let's arrow right, let's highlight, and let's look at both our tables. Now, one of the questions was, at what year will the trees be the same height? And I'm just curious, is that going to happen? Are the trees ever going to get to the same height? Is the slope of the increase of the second tree ever going to make it? Never. They're never going to end up being that same height. Okay. Which type of tree will be taller after 8 years? Well, I just happened to stop at 8 years here, and it really was just happened. I hadn't read that problem yet. So which type of tree is taller? Well, the tree that pretty much started out to be taller, right? They're not ever the same height at any one point, but this tree was only ever smaller the first year, and then they surpassed each other. So there we go. And then this one surpassed, and that was it. So type A. Tree type A, or if you want to write A of X in there, that's the tree that ends up being taller after 8 years. Okay. So notice once I've created those linear functions, I can just plug them into my graphing calculator and compare. It's kind of nice. That's why we learned how to do that. We're going to continue doing that, but we've got to start graphing some linear functions first so we can start comparing those slopes as they increase. So, guys, continue to practice with your slope and applying your slope, and make sure you can look at a line and know it's either positive, negative, 0, or undefined. Okay? I will be seeing you guys for graphing soon. And good luck with all this. Let me know if you need any help. Bye.